Okay, on to page 3. Now I've gone ahead and done all the solutions rather than trying to do them live. Trying to do them live was just too fiddly and tricky. So I've done full solutions and I'll just explain them. So question 4, simplify using the following index law. Excuse me. Okay, so we're multiplying through with the same base. We can just add the indices as I've done there. So a squared times a cubed is a to the power of 2 plus 3, which is a to the power of 5. Now here we're multiplying by the same base in all of the three numbers. R to the power of 4, R to the power of 3, R to the power of 2 gives us R to the power of 9 altogether. 4 plus 3 plus 2 equals 9. Okay, now in the case of 4C, we have S and T. We have the base S and the base T, and we have base S, and the indexes for that base are 2 and 4, so we can add them because we're multiplying. And then T, 3 plus 3, we add them because we're multiplying. So we end up with S to the power of 6, T to the power of 6. Okay, this one. So if we look at all of the numbers to base x, we've got x to the power of 1, x to the power of 1. So we've got 1 plus 1. Then we've got y to the power of 4 and y to the power of 2, this one here. And then we've got z to the power of 1 and z to the power of 1. Now, because we're multiplying these bases, we can add their indices. So we end up with x to the power of 2, y to the power of 6, z to the power of 2. Now, down here, now when we have numbers like this, we call them coefficients. We multiply the coefficients, so it's 2 times 3. And because we have these numbers in multiplication being multiplied and they are in index form and their bases are the same, we can add their indices. So 2 plus 3. That's 2 times 3 is 6, and then a to the power of 2 plus 3 is a to the power of 5. Okay, for f, we have 3 coefficients here. We can multiply those. 2 times 3 times 3 gives us 18. Now we've got 3 numbers with a base a. We've got a to the power of 4, a to the power of 1, and a to the power of 1. So I've got a to the power of 4 plus 1 plus 1, which gives us a to the power of 6. Then we've got 3 numbers with the base b. So we've got b to the power of 7, b to the power of 1, b to the power of 4. 7 plus 1 plus 4 gives us b to the power of 12. Okay, number 5. Now these are division, and when we are dividing numbers in index form, with numbers of the same base, we subtract the indices. So we've got 2 numbers here, x to the power of 4, x to the power of 3, so it's 4 minus 3 equals x to the power of 1, which we simply write as x. Right, here we have some coefficients, so we cancel the coefficients in a division problem like this. So it's 4 divided by 2, which just becomes 2. And the numbers in index form, the base a, we've got a to the power of 3, a to the power of 2, gives us a to the power of 1, which we just simply write as a. 2 times a, 2a. This one here, we have, when we get division and multiplication together like this, it's a bit tricky. But what we're in effect doing here is we've got 2 numbers with the base r, and we're dividing those. So r divided by r. So r to the power of 3 divided by r to the power of 1 gives us r to the power of 3 minus 1. And then it's r times s, so that's where that times comes from, multiplication comes from. And it's s to the power of 4 divided by s to the power of 3, 4 minus 3, which is r to the power of 2 times s to the power of the 1, which we just write as r squared s. Now d, there's a lot of stuff in here, but if we just work through it steadily, we have the two coefficients, 15 over 12. We can just write as a fraction there for now. And then we've got the numbers with the base x. So we've got x to the power of 2 and x to the power of 1. So that's x to the power of 2 minus 1. And we've got the numbers to the base y, y to the power of 3, y to the power of 1, 3 minus 1 there. And we've got the numbers to the base z. So I've got z to the power of 2 and z to the power of 1, which we've got set out there. So if we cancel 15 over 12 through by 3, we get 5 over 4. X to the power of 2 minus 1 is x to the power of 1. Y to the power of 3 minus 1 is y to the power of 2. Z to the power of 2 minus 1 is z to the power of 1. So we can write that as 5x y squared z all over 4. Okay, don't worry too much if some of this is confusing at this stage. You've just got to get used to unpacking these things. They're rather dense mathematically, and it'll just take you a while to get used to working with them. Don't feel like you need to be an expert or understand everything that's going on at this stage. And remember, as long as you've shown me some working, I'll be able to see what you can understand and be able to what you do understand and be able to give you some marks for that. Okay, number 5e, got 19 and 6 are the coefficients here. So put those out like that. Now m to the power of 5 minus 5, because it's this 5, m to the power of 5 divided by m to the power of 5. And we've got a division for n2, the numbers to the base n, n to the power of 4, n to the power of 1 here, 4 minus 1. And 19 over 6 won't cancel because 19 is a prime number, so it just sits there. And we've got m, 5 minus 5 is 0, m to the power of 0. 4 minus 1 is 3, n to the power of 3. So what we've got is 19 over 6 times 1, which is the m to the power of 0, times n to the power of 3, which we can write in a compact form as 19n cubed all over 6. Alright, now simplify number 6. Simplify the following using the zero index rule. Remember, anything to the power of 0 is equal to 1, so a to the power of 0 is just 1. Now this one here, the only thing that's to the power of 0 is the b, the number with the base b. So you've got 3 times b to the power of 0, which is 3 times 1, which is 3. Now everything inside these brackets here is the base, because the power of 0 is to the bracket. So that makes everything inside the bracket the base. So it's just everything to the power of 0 is equal to 1. Alright, now here this is 2 times p to the power of 0. The power of 0 just applies to the p, minus 5. So it's 2 times p to the power of 0 minus 5, which is 2 times 1 minus 5, which is 2 times 2 minus 5, which is negative 3. Alright, having a look at question 7. Using all the index norms you have learnt, simplify the following. Alright, well, we've got all the numbers here are to the same base, so we can work with those. So it's m to the power of 2 plus 5 minus, because there's a division here, minus 3. 2 plus 5 minus 3 is 4, so it's m to the power of 4. Alright, okay, what I've done here is you've got the top part of this fraction here. So you've got two numbers here, both to the base x, so it's, and they're multiplied, so it's x to the power of 5 plus 3. And this fraction bar, remember, means it's a division, so we're dividing here. Now the numbers underneath are both to the same base, so we can add those because there's a multiplication here underneath the fraction bar. So that's x to the power of 4 plus 2. Okay, so that's x to the power of 8 on the top, divided by x to the power of 6 on the bottom, which is x to the power of 8 minus 6 is equal to x squared. Alright, I'm not sure how we're going with time, So I might